Chapter 6, Trigonometric Functions of Angles. 6.1 is about angle measure. An angle, AOB, consists of two rays, ray 1 and ray 2, with a common vertex, O. Interpreted as a rotation of the ray 1, onto ray 2. Ray 1 is the initial side, and ray 2 is the terminal side. This is ray 1, we have point A on it. This is angle O. This is ray 2, has point B on it. We start at ray 1 and go up to ray 2, so this is initial, and this is the terminal side. If the rotation is counterclockwise, the angle is positive, like the example before. If the rotation is counterclockwise, the angle is negative, like this one. We have ray 1 with point A, angle O. Here's ray 2 with point B. And we start at the initial ray, and we end at the terminal, and the angle is negative. The measure of angle A is the amount of rotation around the vertex required to move ray 1 onto ray 2. A degree, 1 unit of measurement for angles. 1 degree is formed by rotating the initial side 1/360th of a complete revolution. Radian measure. If a circle of radius 1 is drawn with the vertex of the angle at its center, the measure of this angle in radians, which we call rad, is the length of the arc that subtends that angle. So we have our unit circle inscribed with its center at the origin is our angle theta. This symbol is symbol for theta. So, for example, this is 1, and then right about in here, this angle will be 1 rad. If we go 180 degrees around it, it's pi rad. It's a 90-degree angle. It's pi over 2 rad. We could also have as many as, it's not quite right. Let's redo that. Right in here, this is 1, this is another 1, so this would be 2 rad. So there is a relationship between degrees and radians. 180 degrees is called pi radians. 1 radian is equal to 180 degrees divided by pi. 1 degree is equal to pi divided by 180 degrees. To convert degrees to radians, multiply by pi over 180. To convert from radians to degrees, multiply by 180 over pi. You're going to find that 1 radian is equivalent to 57.296 degrees, and 1 degree is equivalent to 0.01745 radians. When you're converting between radians and degrees, we'll do some examples. So we're going to express 60 degrees in radians. So we take that 60 and we're going to multiply it by pi over 180. And they're both in degrees, so the degrees are going to cancel. And we can actually reduce the 60 over 80, and this will take care of a lot of computations. 60 will go to 1, 80 will go to 3, and we get pi over 3, and because we're in pi, it is radians. And that's how we're known to express things. We're known to lay things in terms of pi. We're known to express pi over 6 radians in 2 degrees. So we are taking our pi over 6, and we are going to multiply it by 180 over pi. Now 6 is not in degrees, so our answer is going to end up in degrees. The pi's are going to cancel. We're going to get 180 degrees divided by 6, and that goes to 30 degrees. So when we're solving, we're going to be saying theta equals 30 degrees, or theta if it's not in degrees, it's going to be theta equals pi over 6 rad. Angles in standard position. An angle is in standard position if it is drawn in the xy plane with its vertex at the origin and its initial side on the positive x-axis. So, positive x-axis is right here. This is its initial side. We could go up to the other side, and that would be a positive angle. We could have a negative angle by going clockwise. It can go more than one complete rotation and end here. Two angles in standard position are coterminal if their sides coincide. So that means your angles fall in the same quadrant. Our first example is considered coterminal. We're going to find angles that are coterminal with the angle theta equals 30 degrees in standard position. So to do this, we add any multiples of 360. So we take our 30 degrees and we add 360 and we get 390. This is going to be coterminal. It's going to do a complete rotation and then 30 more degrees. So 30 degrees plus 720, and we'll get 750. There is infinite amounts of these that we can do, but we're probably only going to list 2. We could also go and find the negative angles. What we just found was the positive by subtracting multiples of 360. So we take 30 degrees and minus 360, and we get negative 330 degrees. We take 30 degrees and minus 720 degrees, and we're going to get negative 690 degrees. So if theta is given to us in radians and we want to find coterminal angles, we're going to, for positives, add multiples of 2 pi. So we take theta, which is pi over 3. We add to it 2 pi. And we express this in reduced improper fractions. So our denominator is going to be 3. And we're going to get 7 pi over 3. Go pi over 3 plus 4 pi. Denominator is going to be 3, so it's going to be 13 pi over 3. And pi goes in the numerator, it's not out to the side. If we wanted the negative angles, we are going to subtract multiples of 2 pi. So we take our initial theta, pi over 3, subtract 2 pi, and we get negative 5 pi over 3. Take pi over 3 minus 4 pi, and we're going to get negative 11 pi over 3. Find an angle with measure between 0 and 360 that is coterminal with the angle of measure 120 degrees in standard position. So we're just going to take 360 away from 1290 enough times until our answer is in between 0 and 360. So let's take a 360 away. We get 930. Take another one. And we get 570. Let's take 570 minus another 360. We get to 210. So we finally reach a degree that is in between 0 and 360. And our answer is 210 degrees. It had to do 3 complete rotations by the subtracting of 360 before we found our coterminal angle.